Hello, everyone. This video is to explain the shear stress deformation on inclined surface in a bar under axial tension, right? So if we have a bar like this one, right? So if you stretch it, right? So you can see it's elongate, right? The cross sections, on all the cross sections, there's normal stress when you stretch it, right? So we know the stress equals the force divided by the area, right? And the deformation is pretty uniform, right? So you can see the distance between the cross section represented by this ring of this slinking. You can see they're pretty uniformly distant, right, from each other. So that means pretty uniform stress and uniform strain, uniform deformation, right? So if we draw a line, let's say this piece of make it bigger, right? So on this piece of rubber band, so you can see when you stretch it, the distance between the lines increase, right? So that make it so it is showing the uniform deformation, right? So it's normal deformation, elongation, right? So you can see the distance change there. However, right, if you look at the inclined surface, that's basically the surface with an angle, right? So as I'm showing here on the other side of this drawing here on this rubber, okay? So now if I stretch it, okay? So if you observe the vertical lines, right, that the cross section, you can see their distance increase. But if you paying attention to the line with the angle, right, the tilted line, basically representing the inclined surfaces, right? So they are, you can see initially they have like about 45 degree, right? So when I stretch it, you can see the angle change. It's not 45 anymore, right? So if you look at the angle, I mark alpha beta. I'm not sure you can see it, but you can see their direction, right? So they the angle change, right, is basically a little bit more towards the longitudinal direction, right? So initially it's this angle, then you tilt. Okay, so that means there's rotation, right? So rotation means shear strain, right? That's angle change, that's shear strain. So there is a shear deformation. So it must be a shear stress as well. So in a bar, right, under axial tension, right? So you can see on the inclined surface, right, there is a rotation, there is a shear deformation, and thus therefore shear stress as well, right? So that kind of illustrate shear on the inclined surface. All right. Thank you.